Hi, students. We're going to go over and review elements and compounds that we talked about earlier last week. And then we're going to today start talking about mixtures. So we're going to review first what an element and a compound is, and then I'll introduce to you mixtures. So just as a review, remember that a pure substance can be either an element or a compound. A pure substance has nothing but that substance in the sample. If you have two atoms touching and they are the same type of atom, in this case, they look the same because they're the same color and the same size, that means they're the same atom of that element, and that is considered a molecule of the element. That is a pure substance. A molecule of a compound is also a pure substance. A compound is a substance that has two or more different atoms chemically combined in specific ratios. So in this case, this particular compound has two atoms of one type of atom and one atom of another, chemically bound together in that particular ratio. Another pure substance that you might see is just the atom of the element itself, where you just have one atom of that element, which is considered atom of an element. All elements are on the periodic table. And remember that elements cannot be separated into a simpler substance by either physical or chemical means. And we express elements by using symbols. Symbols are a capital letter or a capital letter with a lowercase letter next to it. That's how we know that we have an element. Compounds are pure substances composed of two or more different elements joined by chemical bonds. They have a specific ratio that's going to always be the same. They're represented by chemical formulas. So here are three examples: H2O, NaCl, and CO2. That's water, pure water, table salt, and carbon dioxide. Compounds can only be separated by chemical means. So in order for them to be separated, a chemical reaction has to occur, which gives you different products as an output. All right, so mixtures are a little different than compounds and elements. They are not pure because they are a combination of two or more pure substances in one place at the same time. They are mixed together. They are held together by physical forces, not chemical forces. So no chemical change takes place when you put them together. And each item in that mixture is going to retain their own properties in the mixture. And of course, you can separate out the components of a mixture. You can do that by either crushing them or melting. You can separate them. There's lots of other ways that you can separate out mixtures. So here you can see the different ways to separate out mixtures. You can use a magnet to separate out iron from sand. You could use a filtration device, which separates out the solid from the liquid. You can evaporate out particles from the other particles. For example, you can evaporate out the water from salt if you have salt water. So just keep in mind there's different ways that mixtures can be separated. And when you do that, you're not changing the substance at all. You're just moving them out of the substance, and they still retain their original properties. So just keep in mind, this is a nice chart to just use as a reference about the difference between mixtures and compounds. Some examples of mixtures would be our air we breathe. Okay, when we breathe in air, we're breathing in the mixture air. There's lots of things that we're breathing in, Okay, so in air, we have over 80% of air is nitrogen gas. It's the diatomic um, molecule of the element nitrogen, which means there's two nitrogen atoms combined together to form that molecule. That's the same thing with oxygen gas that we breathe in. That's what we use for cellular respiration. Um, we also find water vapor in the mixture of air, among other things like a little bit of carbon dioxide and methane gas. Seawater is also a mixture, and most rocks. Some examples of compounds is pure water, okay, pure H2O, carbon dioxide gas, which is CO2, which means it's one atom of carbon combined chemically to two atoms of oxygen. Magnesium oxide, which is a type of salt, and same with sodium chloride, which is also table salt. So I'm going to show you a series of photos, and you're going to tell me whether or not you believe that it's showing you an element, compound, or mixture. So just to review, remember that an element contains just one type of atom. A compound contains two or more different atoms chemically joined together in a specific ratio. A mixture contains two or more different substances that are only physically joined together, not chemically, and that a mixture can contain both elements and compounds. All right, so are rocks element, compound, or mixture? Rocks are a mixture. Copper, element, compound, or mixture? You can find copper on the periodic table. Its symbol is capital C, lowercase u. Element, compound, or mixture? Jelly beans. Jelly beans can be separated. You can take out the black jelly beans and you still have black jelly beans. And you could take out the yellow and you still have jelly beans in the mix. Table sugar. Table sugar is a compound. This is the formula for table sugar. In order to have table sugar, you must have 12 carbon atoms, 22 hydrogen atoms, and 11 oxygen atoms chemically bonded together. And that means that they have to be touching. That is just represents one molecule of table sugar. Element, compound, or mixture. Diamond. Diamond is a actual element. That was a tricky one. All right. It's the element carbon. Okay. It's in its purest form. Tea an element, compound, or mixture? Tea is a mixture. Salt, element, compound, or mixture? Salt is a compound. Okay. Salt contains a 1-to-1 ratio of sodium, which is Na, the element sodium, and one atom of the element chlorine. Neon gas. Neon gas is an element on the periodic table. You'll find it as a noble gas. It's on the far right side below helium. Element, compound, or mixture. Salad. Salad is a mixture. You can take out different components of a salad, or you can add things to a salad. You could have tomatoes in there or cucumbers, and you could pull out the tomatoes and cucumbers and you still have a salad. Pure water. Remember, pure water is a compound, okay? Pure water is only found in as distilled water, okay? Most water that you come across is going to be a mixture because most water has minerals added as well, or even like spring water. Spring water is naturally going to have minerals in with the water. But pure water, which is very rare, contains two atoms of hydrogen chemically bonded to one atom of the element oxygen. So pure water is a compound, whereas tap water would be a mixture. Aluminum, element, compound, or mixture. You will find aluminum on the periodic table of elements, therefore aluminum is an element. Lemonade, element, compound, or mixture. Lemonade is a mixture. There is sugar in there. We could always filter out parts of the lemonade and we still have lemonade. It's just we might not have it as sugary. You could add even more sugar and make it really super sweet. You still have lemonade. Silver, element, compound, or mixture. Silver is found on the periodic table. Its symbol is Ag. Sand, element, compound, or mixture. Sand is a mixture. So here we have how we are going to be classifying matter, which is a review from what we did earlier this week. Matter can be classified as either a pure substance or not a pure substance. If it's a pure substance, you'll know that we have elements and compounds, where when you look at the actual microscopic representation of those two types of substances, that's all you have in the actual substance. That's what classifies it as pure, okay? In pure water, you're only going to find H2O, that molecule H2O. In helium, you will only find that atom of helium. That is a pure substance. If we move to the right side of this flowchart, mixtures are not pure substances. If they are uniform, we call them homogeneous mixtures, which means that inside the actual microscopic, if you look at the sample, for example, this one with tea and sugar, those particles are evenly distributed throughout. Whereas if you have a heterogeneous mixture, those particles are not uniform in composition. Next thing you're going to do is a digital assignment. So go into Schoology now and complete the digital assignment listed there.